We did the conservation of energy.
We completed that?
Yeah.
All of you were present in the last class? Who was not present in the last class?
Last class we had done a recap of the entire chapter. Everyone was there.
Okay. He's saying he was not there. Were you there in the last lecture?
He was there. He did give a few answers. I remember.
Okay, fine. So we have done till conservation, law of conservation of energy. Okay. So anybody, can you tell me what do you mean by law of conservation of energy? So till now, what we have done is work done is given as Fs cos theta.
What's happening on the object?
Then in energy, we found the expression for kinetic energy. Come fast. Okay.
So can you re-explain conservation of energy for an oscillating pendulum?
Yes. So till here we have done. Okay, and we have also done law of conservation of energy. Okay, so those who attended, does it make sense to you?
Yeah.
Till here we have done. So I asked, what is law of conservation of energy? Who asked me the question? Regarding repetition? Yeah. Okay. So what is law of conservation of energy?
So it's like the oscillating pendulum.
Wait.
For the oscillating pendulum.
No, it's universal for anything.
Energy can neither be destroyed nor be created. It is only
You can
be converted from one form to another.
let the person answer when it is asked. We'll follow that discipline. So what she said, you agree with that? Okay. So everybody understand what is law of conservation of energy. She asked, explain law of conservation of energy in case of oscillating pendulum. So basically what it means is total energy of an object will remain constant during oscillation and during free fall. Okay. So let us say we have an oscillating pendulum like this. Okay. So this is the path of oscillation. Let us say these are the three positions, A, B and C. Okay. So imagine this is the ground level, or this is level 0 for the bob at mean position. B is the mean position, right? And what is the height? Let us say h is the height at A with respect to B and at C with respect to A. Okay. So what is the reference? Reference is the base of the bob position at B. This is the B position. So here we'll treat the height of the pendulum as 0. With respect to this, the level of the pendulum rises by h on both the extremes A and C. So now imagine for the pendulum to be oscillated, we have to lift it at A and then leave it. Okay, for example, like imagine this is a pendulum.
Okay, that camera moves like a pendulum. The rod.
So this is a pendulum. Now I took it at A. This position is B, the main position. Took it at A and left it. Now it is oscillating. So I took it at A and left it. So now it is oscillating. So you have to tell me what are the energies as at respective location. So first at A, what is the velocity at A? 0. Always at the top position the velocity has to be 0. If the velocity is 0, what will be kinetic energy? 0. Half mv square. Right? Wherever the velocity is 0, the kinetic energy will be 0. So kinetic energy here should be equal to 0. And kinetic energy at C also should be equal to 0. Okay? Because it is the top position. What about potential energy? Imagine its mass is m. So over here, what is the potential energy? mg h. Potential energy is given as, it depends only on the height. Rest is mass of the ball. G is same everywhere. The potential energy at this point is mgh. What is the total energy? Ek plus ep. So total energy is kinetic plus potential energy, always. So total energy is mgh plus 0, which is mgh. Now, when this bob travels through B, what is the h now? H is 0. If h is 0, then potential energy must be 0 here. Since h equal to 0. Likewise here, since V is equal to 0. Here also. Since V is equal to 0. Okay. Now what about the potential is 0 because h is 0. What should be Ek then? By conservation of energy, the total energy everywhere throughout should be same. So if Ek is 0, then what should be Ek? What is the total energy here? mgh. So to make total energy mgh, Ek must be mgh. Because mgh plus 0 is mgh. Okay. So whatever was potential, it got converted into kinetic at main position. Okay. So this is now mgh. So what should be the velocity here then? Because Ek is nothing but half mv square, which should be mgh. So V is equal to square root 2gh. Okay, this is the velocity at main position. Because by conservation of energy, you know that kinetic energy must be equal to mgh. So with what velocity it will cross? Root 2gh. Understood? This is what it is. Obviously, then what is Ep here again? Potential energy must be mgh. So total energy again, Ep plus Ek is, here also Et is mgh plus 0 is mgh. And here also Et is mgh. Because 0 plus mgh will be mgh. So this is the meaning of law of conservation of energy. Conservation of energy means energy is same throughout the oscillation at all positions. At extreme position, it only has potential energy. At main position, it only has kinetic energy. But in between A to B and B to C, it has both. Okay? And the nature of energy is changing. Potential reduces and gets converted into kinetic. At main position, totally becomes kinetic energy. Okay? At main position, totally becomes kinetic energy. Again, as it goes to extreme position, becomes potential energy. In between, it is both. One is increasing, the other is decreasing. So that's the meaning of conservation of energy. Understood? Okay, let's go ahead. With this, we come to the last topic, which is rate of doing work. Rate of doing work. Okay, or it is power. Okay, how to differentiate between who is doing faster work, right? So for that we need to find the rate of work done. So power is defined as the rate of work done. So for example, let us say you have some work to be done by two people, A and B. Right? A does it in 10 minutes, B takes 5 minutes. So who is more powerful? B, because he is able to complete the work faster. So that's why we define mathematically, therefore power is what? Work upon time. Okay? This statement, mathematically, it is expressed as P is equal to W by T. Further, we can write, now what is W? F into S and this T. Because force, work is force into displacement and S upon T is velocity. Hence, V is equal to S upon T. Okay. So these are different formulas for power, and we also know that work is same as energy. So power can also be written as E by T, since W is same as E. Isn't it? Work and energy are interrelated. Both units are joule. Okay. So we can write power as energy upon time. So is it clear? This is what is power. So what are units of power? Power units. So W by T is joules per second, right? So joules per second. This is also called as watt. So unit of power is watt. Watt is equal to joules per second. That is 1 watt equal to 1 joule per 1 second. So how the unit of power is defined? When 1 joule of energy is spent in 1 second, okay, then the power is 1 watt. That's how it is defined. And there are bigger units of power, kilowatt, (1,000 watt). We have megawatt equal to 10 raised to 6 watt. Okay, this W, when it is written as unit, is watt. Okay, and in the formula it is work. Okay, so be clear. This is just illustration. Then power has another unit called horsepower. Horsepower or HP. Okay, so 1 HP is equal to 746 watt. One HP is equal to 746 watt. Next is commercial unit of electrical energy. Am I going too fast? Huh? Anybody has any doubt till here? How many formulas for power? 4?
3, I mean, which one value is it?
Yeah, finally 3, but we can take like the middle one also as 1, depending upon what's given in the numerical. Okay. So 3, the box 3. Okay. So now we really come to the last part, which is electrical or commercial unit of electrical energy. So from here, what can be energy in terms of power? Since P is equal to E by T, so this gives energy is equal to power into time. Okay, so we define 1 unit of electrical energy when power is expressed in kilowatt, when time is expressed in hour, kWh. Okay, so the electricity bill that you get at home, so monthly billing happens on how many units you have consumed. So unit means kilowatt hour. Okay, so we'll express it in joules. So what is kilowatt? Kilowatt is 1000 watt. An hour is 60 into 60, 3600 second. Okay, so this will become 3.6 into 10 raised to 6 watt second. And what is watt second? So this is joules per second. Watt into second is joule. So this is 3.6, 10 raised to 6 joule. So 1 unit. So 1 unit. So 1 unit is equal to 3.6 into 10 raised to 6 joules. This is unit in which system? SI. Okay. So with this we come to an end of this chapter. Right? So we'll do some questions. So this is the full entire formula summary of this chapter. Huh? So you can now, before doing numericals, you should have this written somewhere in the margin. Okay. So if you're done writing, we'll do the exercise. Just give me the volume. Volume 2. Everybody has textbook
Yes,
or
sir.
volume?
Yes.
Those who have textbook, open the textbook.
I don't have the latest textbook. I have like
That's okay, that's fine. A year before has more resource than the
Yeah,
recent
that's
one.
true. This year everything was almost omitted. My sister says we got it easy.
Reduced portion you got.
Yeah.
Okay. Now what you do is so the thing is those who have volume, okay, they will hide the answer. Those who have textbook, open the textbook. Okay? So I think the NCERT questions are given. We'll discuss that.
Is it the exercise questions?
Yes. Same exercise question. Okay? We do that. So everybody has volume or textbook?
Yes.
Okay. We begin with the first question. Hide the answers. Those who have
I
volume.
just read the volume.
So question number 1. Look at the activities listed below. Anybody still writing? So finish writing. Finish writing fatapat, then we'll do 50. What's the page number in volume?
59.
59, yeah, first question. Done? Okay, let's. So we go in order. We start with you.
Sir, Soma is swimming in a pond. Sir, negative work.
Soma is swimming in a pond is negative work. Why?
Sir, because she is going against the water. Against the water.
No, it says reason out whether or not work is. You just have to identify whether work is done or not. Okay?
Yes, sir.
Work is done? Yes. So is it negative work or positive work?
Sir, our teacher told us negative.
So why negative, why positive? Your teacher told what, why it is.
Sir, because it's against the water, means it's in the opposite direction.
The force applied is on the flow of the water and we are swimming in the opposite
Listen.
direction.
Yeah.
She is swimming in a pond. So first of all, in pond water does not flow.
That's
It's not a river. Okay? So let us say a swimmer is swimming in this side. Okay. So basically what she is doing, she is doing this, throwing the water like this. So she is applying force in reverse direction and slipping in forward direction. So force applied is in this direction. And this, she is displaced in this direction. That's why it is negative. 180 degree. So answer is yes, work is done. Positive or negative, you can make out like this. The angle between force and displacement decides work is positive or negative. Okay, so this is negative. Got it? Next.
a donkey is carrying a load on its back.
So is the work done?
Yeah.
It has,
So
it has
donkey
potential and
is
it's
in this position. The donkey is not moving. It's in
so it
this
is not
position.
work done.
So it's
Where is the load here?
Yeah.
Donkey is not moving. What is it?
but carrying the load on its back.
Carrying a load on its back. Obviously, he is carrying, he must be moving. Let's say he is moving in this direction.
So work not done, sir, 98 degrees.
Yes, smart boy. So what's the formula for work? Fs cos theta. Cos 90 is 0.
Zero.
Okay? So
Zero
no,
work is done.
no work done.
So it's the same if I'm like holding a bag, like a suitcase.
Whether he is moving or not moving, work is not done. If not moving, displacement 0. If moving, displacement and force 90 degree. What is the force? Weight. Weight of the load. What is the angle? Theta equal to 90 degree. So cos 90 is 0. No work done in either case. It's a good donkey. Okay.
A windmill is lifting water from a well. Work is done.
Work is done?
Yes.
How?
Because the water is being lifted.
Yes. So if the windmill is moving, let us say there is some pulley. There's a bucket. Okay? When the windmill is moving, so this is going up. So F is up and displacement is also up. So there is a work done. Force and displacement, taking the displacement in the direction of force. So yes, work is done. Positive, negative?
Negative.
Negative.
Because
Positive.
against the
Positive.
They're positive.
Sir, positive.
Who is lifting? Windmill.
Yes.
Whose work we are asking? Gravity's work or windmills? Windmill. So windmill is, I said, two work is done in a situation depending on the context. Okay. So work, yes, work is done. And it is positive since theta is 0. Force and displacement are parallel. Positive. Cos 0 is 1. So cos 0 degree is equal to 1. Cos 90 degree is equal to 0. Cos 180 degree is equal to -1. Okay? Next.
A green plant is carrying out photosynthesis. Work is not done
Why?
because there is no displacement.
And there is no force. Chemical. Huh? Okay, good. Next.
And an engine is pulling a train. Sir, the work is done because an engine is
Exerting force.
exerting force on the train.
And the train is moving ahead. Correct. So fourth case में no work done. Not done. Fifth में done. Yes. Yes, no, yes. Okay. Yes means work done. Okay. And it will be positive, of course. In this example, what is the work done by friction? Positive or negative?
Sir, positive. Sir, it's positive. Right?
Friction, not engine. Engine is
Engine it is negative because it is in the
engine work is negative.
Sir, it was a friction, it is opposite.
Friction is negative. Okay, because friction always acts against the motion. Always in every situation, friction is a opposing resistive force. Okay, friction always works against the motion. So frictional work is negative. Okay. So sixth, do we have something else?
Food grains are getting dried in the sun. So work is done because there's like a what do you call it? It is losing water. So
That is chemical.
Here this entire chapter is about mechanical work. There has to be a force and there has to be a displacement. Where is the force? Where is the displacement? Is work done? Not done. Understood? So work not done. Last.
A sailboat is moving due to the wind energy. Work is being done because the wind energy is pushing.
Yes. So the displacement is in the direction of wind. Okay. So work is done and it is positive. Okay. So when force and displacement are in the same direction, then work done is positive. Negative is when force and displacement are in opposite direction. So I think this should be now very clear. Question 2.
An object thrown at a certain angle to the ground moves in a curved path and falls back to the ground. The initial and the final points of the path of the object lie at the same horizontal line. What is the work done by the force of gravity on the object? Right angle. It is 0.
Why?
Because this is a right angle.
How right angle?
Object is thrown at a certain angle.
Ball is thrown.
It moves curve,
It makes
but
a
it falls
curve.
back to the same horizontal line.
Okay. So where is gravity? Gravity is always downward. Where it is 90 degree.
Straight.
Even if you take 45 degree and 90, so 90 plus 45 is 135 degree. Where is 90 degree?
I don't know.
Okay. So anyway, see, gravity is always acting downward, isn't it? At every position. Isn't it? Now, what is the displacement in the direction of gravity? So this is position A, this is position B. So displacement in the vertical direction, what is it? So let's say this is the maximum position C, right? So with respect to Earth, so from A to C, let's say the maximum displacement upward is H. Okay? When the ball is going in the upward direction, when it falls, it covers minus H. What is the total displacement?
0.
0.
So what's the 0?
So therefore, net displacement in this motion is 0 in the vertical direction. Gravity is acting in vertical direction. So force is this, whereas displacement is H minus H equal to 0. You have to analyze the question like this. Displacement in the vertical direction is 0. That's why
Work done is 0.
work done is 0. Okay. Clear? So try to visualize the question by drawing some diagram. Then it will be easy for you to answer. Next,
A battery lights a bulb, describe the energy changes involved in the process. In the battery, chemical energy.
you have to answer,
Oh, sorry.
not read.
Uh,
So what is happening? Battery lights a bulb. What is happening? You have a battery. There's a cell like this. Okay? So you have a bulb. So when you switch it on, press it, then it glows. What is happening? So inside the battery you have electrode and electrolyte. This is the electrode and you have electrolyte around it. Right? In electricity, in 10th standard you will read about it. But in chemistry, have you studied about cells? Have you studied about electrolyte, etc.? Have you
Yes, sir,
studied
we have
about it?
Yes.
So the battery basically,
In 8th grade, we studied.
so in battery you have two electrodes and some electrolyte. So there is opposite type of charge on the electrodes. So one is positive and this is negative. The casing is negative and this is positive, the rod that is. So because of positive and negative charge, there is a potential difference which makes the current flow through the bulb. So what is happening? So when the current is flowing, it is electrical energy. How this electrical energy is coming? Due to the chemical energy taking place in the cell. So if chemical energy is converted into electrical energy, then it is converted into light and heat. So what is the energy conversion? First it is chemical energy to electrical to light and or heat and light you say.
Sir, can you turn off the AC?
Yeah. Heat and light. Whose demand it is?
Everyone's basically is very
So, sir, can then say turn on this fan?
No, sir, it's very cold. Ask them to sit ahead.
It's not.
Take it easy, boys. I'll switch it on. Let it become little warm.
At least turn the fan on instead
No.
of this.
Don't think about it. I'll give it 2 minutes. Right now, if the fan turned on, it will be more cooler than the AC. Okay? So wait, because there is a cool air. Okay. So is the energy changes understood? So nothing is created, nothing is destroyed. There is just energy conversion happening from one form to other form. Your turn.
A certain force acting on a 20 kg mass changes its velocity from 5 meters per second to 2 meters per second. Calculate the work done by the force.
Okay. Can you do it? Which formula? Oh, the formulas are erased. Work done is equal to change in kinetic energy. That formula.
Oh.
Because the velocity is changing, that means their kinetic energies are changing.
Final minus initial.
Yes. So the change in kinetic energy is equal to the work done. Do that.
That would be
So how
3.
much? Half mv square minus half mu square. You can do 1 by 2 m v square minus u square. This is the formula. So you can simply write it as, or w is equal to half m v plus u into v minus u. Now do that. This is how the calculation becomes simple. So half into 20. What is final velocity
2 meters per second.
and initial?
5 meters per second.
So final is 5, initial is 2.
Oh. No, because the mass changes its velocity from 5 to 2.
Acha, 5 to 2. Okay.
Yeah,
okay.
it's not.
2 minus 5. Okay. So this will be what? 7 into minus 3. So 21.
Minus 21 upon 2, right?
So it's a negative minus 210 joule. So work done is 210 and it is negative against the motion. So therefore 120 joule of work is done against the motion. Because the speed, the final speed is less than the initial, right? Yes, your turn again.
A mass of 10 kg is at a point A on a table. It is moved to a point B. If the line joining A and B is horizontal, what is the work done on the object by the gravitational force? Explain your answer. Sir, in this case, the work done will be 0 because the force and the displacement the place where it has gone is like 90 degrees.
Yes. So everybody understood? Let us say you have a table and initially the mass is kept at position A. Okay, and then it is moved to position B in a horizontal line. So let's call this as position A, this is position B. When you join this point, this is the direction of displacement. And all throughout the weight is the downward direction. And this is this, 90 degree. W is equal to 0. And this cos 90 is. Okay. So when you move it from A to B, should I write A and B here? This is position A, position B. You join these 2 points. Okay, since force is perpendicular to displacement, write like this. Since force that is weight. What is force here? Weight is perpendicular to displacement. This is question number 5. Next.
The potential energy of a freely falling object decreases progressively. Does this violate the law of conservation of energy? Why?
Does it violate the law of conservation of energy? Look here. I said hide the answer. Only then you can look at it. So, when the object is falling, at the top position it has maximum potential energy. So, its potential energy reduces as it falls down. So, potential energy reducing. Is it a violation of law of conservation of energy?
No, then
No.
the kinetic energy increases.
Yes, because the amount by which the potential energy reduces, the same amount is now converted into kinetic energy. So the total energy remains same. Okay, so what's the answer? No, the law of conservation of energy is not violated because the potential energy reduced is converted into equal amount of kinetic energy. Okay. Which is the law of conservation of energy. So it's a logical question, right? Next.
State the various energy transformations that occur when you are riding a bicycle. Sir, the muscular energy of the person riding the bicycle, it gets converted into the mechanical energy.
Mechanical energy of?
Mechanical energy of the bicycle.
Yes, of the bicycle. So person is sitting here on the cycle. Okay. And is pedaling. Okay. Where is the cycle? Imagine this is the cycle. So when he pedals it, so muscular energy is converted into mechanical energy of the cycle. Okay. Person himself is also moving, so it's everybody is same. Just the mass into velocity square will be person's kinetic energy. Okay. So muscular energy to mechanical energy. Okay. Is there any other? See, in sweat, heat also ठीक है, but muscular to mechanical. Next. So which mechanical it is? Mechanical in this energy is only kinetic energy. Does it have any potential energy?
No.
No, because there is the level changing. It's on the same level, so no change in the potential energy. Potential energy only when there is a change of position with respect to ground. Okay, at the same level, only change is taking place in kinetic energy. Because that formula, work done is equal to change in kinetic energy. No level difference. Okay. Next.
Does the transfer of energy take place when you push a huge rock with all your might and fail to move it? Where is the energy you spend going? It converts into potential energy.
What is the question? Does the transfer of energy takes place when you push a huge rock with all your might and fail to move it?
No. Potential energy turns into kinetic, but there is no change of height.
Is there any displacement taking place? So there is no energy transfer. If you would have succeeded in transferring the energy, then stone would move. Okay? But you still get tired in the process. So you are spending energy, not mechanical. Which energy are you spending? Chemical. So your chemical energy is getting converted into what? heat. So when you press your hands, press your hands. Is the temperature rising? Little bit, right? Press your hands. Press it little hard. Is the temperature rising?
Yes.
Yes, you can feel it, right? So all the energy that you applied, no movement happened, got converted into
Heat
heat energy. That's what will happen. Okay? So muscular to heat, no kinetic energy. Right? So muscular. So here muscular effort. So muscular to heat, no kinetic energy. Next.
A certain household has consumed 250 units of energy during a month. How much energy is this in joules?
So how do we do it?
Here.
250 units in joules is how much? So how much 1 unit in joule? 1 unit is?
Kilowatt hour.
1 unit is 3.6 into 10 raised to 6 joules. I told you. Therefore 250 unit will be? into 10 raised to 6 joules. This much.
Sir, from the fan.
We can. Okay, now I think nobody should mind. 250 यूनिट में क्या होगा? एक यूनिट में 3.6 था, तो 250 में क्या होगा? 250 times this. Okay, so find out how much is that. And then we'll do the next one. Next class also we'll do more numericals because there's so many numericals. Different types of numericals. Okay, how much is this? So this is 25 into 36 10 raised to 6 joules. So how much is this? 25 6 155. We have 75. 75 plus 15 90. Okay. Right? Is this correct? Alright.
No, sir.
You can reduce it, but
Sir, why?
this one,
Yeah.
this is front.
That is the
I will see you.
It was small.
Okay. Next is whose turn? An object of mass 40 kg is raised to height of 5 meter above the ground. What is its potential energy? This was question 9. See question 9 and the answer is 9. Coincidence. So how much is the object lifted? EP is mgh. 40 kg. And then we take G as 10 and 5 meter. We are taking G is equal to 10 meter per second square. Okay. So how much is this? 4 5 is 20. 2000 joules. If the object is allowed to fall, find its kinetic energy when it is halfway down. So see, it is taken to this height. This height was how much? 5 meter. So when it comes down by 2.5 meter, what is asked is what is its kinetic energy?
The kinetic energy is half mv square.
So what happens to its potential energy at this point? Half of whatever it was at top, because height is half. Right? So full energy minus half potential energy, whatever remains is kinetic energy. So it will be half of this. Got it? If the potential energy reduces to half, that means the remaining half is kinetic energy. Total has to be 2000 only. Got it? So this is the first part. The second part, since E total is equal to E kinetic plus E potential. E total is 2000. So over here, EP will be mg 2.5. So that will make 1000. Okay, at half height. So EP is equal to mg h by 2 at this place. We should write it like this. E total is at full height, which is mgh only. Ek plus mgh by 2. So what is Ek? H minus mgh by mgh 1 minus half. This is half mgh into 2000. So if you know the law, you can straight away write, or you can mathematically find like this.
But how in half calories? How will you find the energy half the
Total energy will remain sum of kinetic and potential. So at half height, total energy to mgh
height?
obviously. When it is falling hard at half height, we want to calculate what is Ek. But potential we know, because at half height only potential is known. So this is total. Total remains same by law of conservation. But potential will be mgh by 2. Okay. So this is the second question is at half height. Okay. Next.
What is the work done by the force of gravity on a satellite moving from the Earth? Justify your answer.
So it is like question 2 only because it will be perpendicular to the force of gravity, so 0 work done.
Yes.
Then question 2 figure only will create.
Question 11 is like this. So this is a satellite. It is always, displacement is always perpendicular to the force due to gravity
Gravity. So the work
at
done
any
is
point.
0.
So W is 0. Theta is equal to 90. Okay? Force and displacement are at 90 degrees. Next.
Can there be displacement of an object in the absence of any force acting on it? And I think this one is very important. So basically, can there be displacement of an object in the absence of any force acting on it?
Yes, discuss with your friend.
If there is no force,
How can there be displacement? That's the question.
Lack of friction, maybe.
Lack of friction maybe in a slanted area.
Lack of friction, and what if there is friction?
Slippery force, like the
Question is,
Can they be displaced?
can there be displacement of an object in the absence of any force acting on it?
Any force?
there can be.
So Newton's first law of motion, yes, sir, can be.
It can be. Very good.
Newton's first law of motion.
How?
When-
This
when-
is
when the-
Newton's.
when there is no
Wait.
force-
Let us wake up some people.
Law of
This
motion.
is first law of motion. What is first law of motion?
Inertia.
It is basically
Object at rest remains at rest,
and object is motion
remains in motion at
balance.
same velocity. Velocity does not change. When velocity is uniform, is there force acting? When velocity is not changing, that means no acceleration. If A0, force is 0, force is mass into acceleration, right? If velocity not changing, there is no force acting. Now answer the question.
So there will be displacement.
It is possible when object is moving with constant velocity. It is possible. When object is moving with constant velocity means there is no acceleration acting on it, na? No acceleration means no force acting on it.
A person holds a bundle of hay over his head for 30 minutes and gets tired.
So what's the
Has
answer?
he done some work or not justified enough?
No.
There is
Sir, no,
no
sir.
work done.
There is no work.
No.
Because cos is equal to 98.
What's the question? Can there be displacement of an object in the absence of any force acting on it? Answer is yes. Justify during uniform motion. Keep it simple. The question is in two parts. Can there be displacement without absence of force? Yes, there can be. When the object is undergoing uniform motion, meaning its velocity not changing. Understood? Is it the same answer in the volume or different?
Same.
Then, so whenever object undergoes uniform motion, no force, no net force is acting. When we say force acting means net force. Motion of the object is due to net force. Okay? So there is no net force. There is a force, of course, somebody pulling it ahead and frictional force, but total is 0. Okay? Alright, next question. Do we have time for next question? Okay, just take a look at what you did today and I'll wait for the bell to ring. So how did you find this chapter? Easy, difficult?
Easier than the previous one, definitely. Easier than gravitation.
Gravitation is just.
How did you find?
Gravitation is comparatively
Good?
easier than
Better, relatively easier.
Yeah.
It's not easier. Your level has gone
I
up.
like this
It is
chapter,
okay.
that's quite fun.
Yeah, I love
What did I say? Your level has gone up. This chapter is full of concepts and now you're able to catch the concepts relatively easily.
the second one.
Okay.
Me too, give me a
Four to five, ये class में 1 फिर next 7 7 8